Hello, everyone. Good day. Welcome to our session today. Uh, for this, I'm going to demonstrate to you the idea about or the concept about best, worst, and average cases. Actually, in computer science, best case, worst case, and average cases, these are actually of a given algorithm express what resource usage such as like running time or time complexity, or it could be a memory or other resources that is going to be running in our computer or within our machine. So in the previous discussion, uh, we have this an algorithm, a problem, and then we were actually able to provide two different solutions, and we were able to evaluate whether the first solution is better than the other solution is better than the other solution. It's like an assessment or evaluation whether in that particular problem, which one is actually the best one, which one is actually the efficient one. And we and then that's the essence of programming, right? We tend to create different solutions out of a problem, and of course, as a computer science, pick we have to select the best one. Now in this case, I'm going to show you the a certain algorithm, and then I'm going to show to you how this best case and worst case and average case is going to be like uh, used in a certain algorithm. So this time we have only one algorithm, and then we are going to perform different scenarios. Okay, so let's start with this. Right here, we have a program which is a basic searching algorithm. This one, actually, what we are going to aim this one is it's going to only search for a certain value, which is this one. We have an algo here, which is found, and it returns a long because we intend to return like the time complexity of each scenario, and then we have here an argument or a parameter which is num, which we actually gotten from here, which actually be gotten from here, and then we have the value that is going to be searched in this specific elements in these elements. So let's write a an algorithm for this, a procedure for this algorithm. Okay, so let's start with the loop first, of course. So we have here, let's say int I is, let's say 0, int I is less than, let's say num dot length, okay, and then we have I plus, and then here in the loop we are going to uh, test or compare each element num I to the value that is going to be searched, which is value. So if ever it is going to be it's found in that the value is found at the element at the array, we are going to end the what they call this one, the loop, no, or the loop execution. Okay, and then so right, we are going to display something like, let's say hold is equal to the value. Yeah, see, is not found. Okay, if ever it is found, we are going to change that hold. Sorry, to change that one, hold is equal to let's say value. Sorry, value is found at index that we have I. Okay, and then what else do we have here? We can also include like number of loop times, but it's not necessary. But let's include that one. So loop times that we are able to say how much loop, how many loops, but this is not necessary. Again, have I, right? And then the most important one is of course the complexity, or I mean the calculation of the time, no, processing time. So let's say we have long start is equal to system. Let's just get the Java uh, capturing the time in nanoseconds. Then we'll have here and okay, and then after that we are going to return the difference between the end and the start. And right here we are going to display uh, the hold. It's going to display hold value or something like. So if we are going to call this one here in our main method, it's going to be the output is going to be like this. So let's say for an instance, we have searching algorithm that find what happened. Sorry, find, and then yeah, we use this num okay elements to pass through here in our find algorithm, and then let's say we are going to just look for like 34. No? So by then we are able to actually display. We have here in the loop times 0, 34 is found at index 0. So let's put here a processing time. Okay. So in the event of like this is actually an example of best case scenario, where our algorithm is actually at best case scenario because it is only going to have, it's actually directly, I mean, there's only one loop time because at that moment, in that event now, in the event of, in that event, at that, yeah, at that event rather, 34 can be easily found because it's in the, and it's in the first position. So in that sense, our algorithm is actually at its best case scenario, and its processing time is actually 798,599 nanoseconds. But what that's the best case, okay? So it's the minimum of number of operations being executed. So because it's lower bound, it's yeah, that's the definition of best case. So let's have here the best case. So that's it. And then so meaning it our program or our algorithm performs well in this at this moment because again the processing time is lesser, okay, because again makita dayon niya directly nga 34, and in fact makita nato sa tuang program na ang iyang loop times is actually this one is 1, so it changes to oops, what happened, we lack one more parenthesis, so it's actually loop times is 1, okay, that's it. So there's one loop and the processing time or processing speed is 234 nanoseconds. In the event of like, what if our algorithm is based on the same algorithm, and then what if we are going to search for a value that is not going to be, we know that it's not going to be, it's not part of that element. So it's, of course, as expected, it is not found. So something like value is not found. It displays something like that, and it has to the processing time is going to be like it's going to visit or traverse from this one to every contiguous element of our array. So which is 34, 89, 10. It's the value is going, this one 100 is going to be compared here, right here. So let's see if there's a, yeah, so relatively we have five. If we get to compare that one in our our best case where we look for 34, and 34 is in first position, we can only have we have only our processing time rather is only 229,008 or 8 nano time. But in this case, we have in our second scenario, which is this time, it looks for 100, but it seems like it did not even find it and it has to go through the process of looking for or looking and comparing for each of the element, and then only to find out na dili niya makita, and that is how many loop times we have. 11 loop times. What if it's 1 million times of loops, right? So the processing time is 512,253 nanotime. So that's so in that sense, in that manner, we are our algorithm now is in it's actually in worst case, no? So it's like upper bound of running time of an algorithm. So it causes the maximum number of operations to be executed. While this one, minimum number of operations to be executed for best case. So this one is the worst case, while this one is the best case. Now, the best case of our algorithm and the worst case scenario of our algorithm. Okay, so and then this is actually our focus in terms of how can we make this efficient. No? Like if we look for 100, and what if it's not part of the element? So how can we possibly make this? How can we possibly make this? How can we possibly create an algorithm that would not actually look for as I mean traverses or visit each uh, element in a linear manner? No, how can we possibly create an algorithm that is efficient in terms of doing so, in terms of searching? Okay, because there are actually a lot of algorithms that does that. It's not actually required to visit all the the, the elements in that all elements in that particular no in yeah in particular array. Okay, which is one of it is actually binary search tree. Okay, which we will be discuss that one in our next topic in the succeeding weeks. Okay, in case of the average case, it's you are actually going to just calculate the running time for all possible inputs, meaning to say, in layman's term, you are going to try like uh, 5 times you are going to search, or I mean 5 times you try to search, and then you get the what is the running time or processing time of that, and then you sum that the you get the sum of those processing time, and then after that averaging tayo, you get the average. In that manner, you are in the it's the average case scenario. So let's say for an instance, we have here, since this is a value returning time, I mean value returning method, we can actually put something like average equals then divided by, let's say 3 lang tataman. Okay, 3 types of searching lang siya. Yeah, it should be long. Okay, let's say we look for 150, and then plus we look for, say, um, this one, 23 in the middle. So let's say 20, 23, and then let's say 10, okay? And then let's just enter this one, and then copy paste, and then let's say we are going to find 10. So among all, what happened? Among all of our, wait. We have, this is the closing, this is the close. So then we lack one more. So we have executed three different I mean we executed three different I mean yeah how do I say this one? We just called the searching algorithm I mean that the find algorithm, and then we give different values to it, and then this would generate or yields one processing time. This would also give us another processing time. We can actually make this one as a loop, and then after that we are going to get the sum and then the average of these three input values. Okay, so now we could now processing time is average or average. So this is in the average case. So in that case, that's the average. So it's really, I mean, average is not the case now for calculating the performance of our complexity, but it could be one of your choices. Okay, so yeah, in that case, we have to still uh, the least time being executed is still the best case because again the value that is going to be searched is found at the index 0, meaning it does not actually require uh, a lot of loops, no, only one loop makita na dayon niya. But in the case of the worst case, it's going to look for the values in, I mean, it's going to visit all the elements of the array and then only to find out na wala na siya makita dito or it's not actually belong to there. It's not actually belong to that element. And then for the average is we just do the averaging, the mean value our for the processing time. And that's how we get the average case scenario. So and as a computer science, our role here is to how to make this here, no? Our focus here, our role here is to make this searching becomes faster in terms of the worst case scenario. Meaning to say, because there are at times that in a worst possible scenario, if in searching there's always this that a value is not being found. So that's our role there. How can we create? How can we? It's our This is our role now to create, to develop, or to come up with a solution that is going to uh, like so that this one will not probably occur, no, the worst case. So again, something like a solution that would prevent from uh, occurring this possible worst case scenario. Okay, so I guess we call it a day. Thank you guys for joining in and have a great day. See you guys soon. Bye bye.